Well, we've got an equation with a radical in it. So what I'm going to do is isolate the radical, which it already is, and then I'm going to square both sides to get rid of the square root. Right? How do you undo a square root? You square. So here's what I'm going to have. The quantity, square root 4x minus 9 squared equals 1 squared. All right, so what I'm doing is I'm just squaring both sides. So when I square the square root, the radical comes off. I get 4x minus 9 equals 1 squared is 1. Let's add that 9, so we'll get 4x equals 10. We'll divide by 4. We'll get x equals 10 over 4, or how about x equals 5 halves? Now, this is a potential solution. This is just potential. There's no way around it. When you square both sides of an equation, you may introduce extraneous solutions. So when you square both sides of an equation, like we did here, I squared both sides of this equation, I can introduce extraneous solutions. That means an extraneous solution is one that may solve one of these equations down here, but it does not solve the original. So I have to check. No way around it. So we need to check. So I'm going to write check, if I can. And I'll say this. I've got one solution here, 5 halves. So I'm going to say if x equals 5 halves, then, all right, put the 5 halves, put your potential solution back into the original equation. So we're going to have this. Square root of 4 times 5 halves minus 9. And I want to know, does that equal 1? 1. All right, well, what happens inside? 2 will go into 4 twice, and then we get square root of 2 times 5 is 10 minus 9. Is that equal to 1? Well, this is the square root of 10 minus 9 is 1. Is that equal to 1? Square root of 1 is 1. Equals 1, and it checks. All right, now that I've checked it, now I conclude that x is equal to 5 halves. But I can't do that until I check. Another radical equation here. So I've got the radical isolated. That means it's on one side by itself. Let's square both sides. So I'll get the quantity, square root 1 minus 7x squared equals 6 squared. Square root, the radical comes off. I get 1 minus 7x equals 36. All right, we can solve this linear equation. Let's subtract 1 from each side. We'll get negative 7x equals 36 minus 1 is 35. Let's divide by negative 7. We'll get x equals, all right, here's what I'm doing. 35 divided by negative 7. I get x equals negative 5. But that is just potential. All right, so we need to check. Let's do it. So I'm going to write check up here. And I will say if x equals negative 5, then, all right, now take that negative 5, our potential solution, and put it into the original equation for x. So we will have the square root of 1 minus 7 times negative 5. Okay, is that equal to 6? So this will give us the square root of 1. Now, negative 7 times negative 5 is plus 35. Is that equal to 6? Square root of 36. Is that equal to 6? 6 equals 6, and I finally got it checked. So now I will conclude that x equals negative 5. Let's isolate this radical. So I'm going to subtract 7 from each side. So I'll get the square root of x plus 7 equals negative 7. Now notice, something's up here. I've got a square root being a negative number. All right, that's just not going to happen. So right away, I can just write no solution right here. But if you don't see it, let's go ahead and square it out. Square both sides. All right, so just in case, here's what we'll get. I'll square both sides so we can see what's going to happen. Square root of x plus 7 squared equals negative 7 squared. So on the left side, square root, the radical comes off. We get x plus 7. Negative 7 squared. Negative 7 times negative 7 is positive 49. subtract 7, we'll get x equals 42. All right, now remember, that's a potential solution. So take that negative 42 and put it back into the original equation, and let's see what happens. All right, so we're taking that 42. I got a positive 42, not negative 42. Take that positive 42, put it back into the original, let's see what happens. So we will get, if x equals 42, then, all right, square root of 42 plus 7, is that equal to 0? Well, 42 plus 7 is 49, plus 7. Is that equal to 0? Square root of 49 is 7, plus 7. Is that equal to 0? Well, 14 is not equal to 0. So we have to toss this out. So toss out 42 as a potential solution. It's just not going to work. But that's the only potential one we had. So we have nothing left. So we will conclude that this equation has no solution. We've got a radical equation in which the radical is already isolated. It's on one side by itself. Let's square both sides. We'll get the square root of 7x minus 1 squared equals 3 squared. Square root on the left, we'll get 7x minus 1 equals 9. Add 1, we'll get 7x equals 10. Divide by 7, how about 10 sevenths? Okay, there is our potential solution. So we need to check. So we will say if x equals 10 sevenths, then, all right, take this 10 sevenths, substitute it back in the original for x. Now when you do this, don't worry about that it's a fraction. The denominators will cancel on us. So we will get the square root of 7 times 10 sevenths minus 1. Is that equal to 3, right? I took the 10 sevenths, I put it back into the original. So now the 7's cancel, and I get the square root of 10 minus 1. Is that equal to 3? Well, that's the square root of 9. Is that equal to 3? And it sure is. 3 equals 3, check. So now I conclude that that x is, what do we say, 10 sevenths. Now I've got a radical that's isolated, and I also notice that I've got x's on both sides. So it looks like when we square, we might get a quadratic here. So let's start by squaring both sides. So we'll have the quantity, the square root of 2x plus 30 squared equals the quantity x plus 3 squared. All right, square the left side, square the right side. Now on the right side, on the left side, when you square the left side, you square a square root, the radical comes off. You get 2x plus 30 equals. Now, let's talk our way through this. We know we have a pattern for this. When you square two terms, you square the first, you multiply the two together and double it. So you multiply them together, you get 3x. You double it, you get 6x. And then when you square the last, square the 3, you get a 9. So now we've got a quadratic equation. And we know how to solve these. We're going to get everything on one side, 0 on the other. Now, my x squared is on the right side, so I think I'll get rid of both of these. Just get 0 equals something. So let's subtract 2x, and then we'll subtract 30. So that'll give us 0 on the left side equals x squared. Now, 6x minus 2x, 4x. Then, plus 9 minus 30 minus 21. All right, now, can we factor this? 0 equals, write the two sets of parentheses, anticipating we can do it. How about x and x? Now, what are two numbers that are going to multiply together to get 21? When you add them, you get 4. Well, there's only two ways to get a 21 and a 1. and I can't get a 4 out of those. But a 7 and 3, I can get a 4 out of those. So I'm going to use a 7 and a 3. This term is negative, so these two numbers, 7 and 3, will have opposite signs. I'm going to put that middle plus sign with the bigger product. Now, the inner product is 7x. That is bigger than the outer product, 3x. So I'm going to put the plus sign here. So I'll get plus 7x minus 3x. Now I can read off the solution. X is equal to negative 7 from here, and from here I get 3. All right, so I've got two potential solutions. Check them. Got to check. So first of all, if x equals, let's go with the negative 7. If x is negative 7, then, all right, put the negative 7 back into the original equation, here and here. So we will have the square root of 2 times negative 7 plus 30. Is that equal to negative 7 plus 3? All right, now, I don't need to go any further. What is this? Negative 4, a radical equaling a negative number? That's not going to work. So no solution. I don't need to go any further. No solution. All right, well, no solution. I don't mean no solution. What I mean is that x cannot equal negative 7. That will give us, that just doesn't work, an undefined expression. So negative 7, we can toss that one out. So down here, I'm going to toss out negative 7 down at the bottom left. Now, number 2, what happens if x is equal to 3? Then, all right, put the 3 back up here into the original equation. Replace all those x's. So we'll get the square root of 2 times 3 plus 30. Is that equal to 3 plus 3? Well, on the left, what do we get? 2 times 3 is 6. 6 and 30 is 36. Is that equal to 6? And sure enough, square root of 36 is 6 equals 6. That one checks. All right, so 3 is okay. So 3 is okay. We'll conclude that x is 3, but negative 7 doesn't work. So we thought there might be 2 solutions, but in fact, there's only one. So here's a radical equation in which we have 2 x's on both sides, one on each side, and an isolated radical. That square root is by itself on the left side. So let's start by squaring both sides. So we'll get the quantity, square root of 7x plus 7 squared equals quantity x plus 1 squared. On the left side, square the square root, we just get the radicand, quantity under the radical. And on the right side, oh, we're squaring 2 terms. We have a way to do this. Just talk your way through it. Square the first, x squared. Multiply these 2 together. X times 1 is x, but you double it. So plus 2x. And then you square the last. Square the 1, you get a 1. This is quadratic. Let's get the 7x and the 7 onto the right side. We'll have 0 is equal to x squared. Now, 2x minus 7x is minus 5x. And 1 minus 7 is minus 6. So let's try to factor this. So I'll get 0 equals, now write the 2 parentheses anticipating we can do this. I'll put in the x's. Now we need to get to 6. I can use, right, to get a 6, I can use a 6 and a 1 and a 3 and a 2. Now if I try the 3 and the 2, I could put the 3 here and the 2 here, right? I could try this, a 3 and a 2. But what the problem is now is that this is negative. So these have opposite signs. Now, if they have opposite signs, I get 3 minus 2 is 1, or 2 minus 3 is negative 1. I can't get a 5. They're going to have the same sign to get up to a 5. So 3 and 2 is not going to work. Let's get rid of those. Let's try the 6 and the 1. So if I go with a 6 and a 1, now this I think is going to work because I have a negative here. These have to have opposite signs. And I'm going to put that middle negative sign with the bigger product. The way I wrote it, the inner product is 6x that's bigger than the outer product, 1x. So I'm going to put this negative sign right here with that 6. So negative 6 plus 1, negative 5. Now from here and here I can read off the solution. X is equal to 6 and negative 1. Now these are potential solutions. So we have to check them both. So how about this? First of all, what about if x is equal to 6? Okay, try that. Then what happens? Well, take the 6, put it back into the original equation here and here. So it'll look like this. Square root of 7 times 6 plus 7, is that equal to 6 plus 1? Well, on the left side, 7 times 6 is 42, plus 7 is 49. Is that equal to 7? 7 equals 7. Looks like it works. All right? So 6 is okay. We'll count that as a solution. Now, what about number 2? If x is equal to negative 1, let's check that one. If x is negative 1, then, all right, put that negative 1 back into the original equation up here. So let's put that negative 1 in. So we'll get 7 times negative 1 plus 7. Is that equal to negative 1 plus 1? Well, what do we get inside? 7 times negative 1 is negative 7 plus 7 is 0. Is that equal to 0? Square root of 0 is 0. 0 equals 0, that one checks. So both of these potential solutions check. So we're going to say that x is equal to 6 and negative 1. You can use either one of those and you'll get a true statement.